Okay, so pure substance and mixture. So pure substance, just think of this as you always have the one type of particle. Mixture, two or more different types of particles. Okay, so we're going to go a little bit further into what are the different types of pure substances that exist. So reminder, pure substances is where you have one type of particle and the composition of that matter is always the same. It's like consistent throughout. So we have here further division in terms of what types of pure substances exist. So we have elements and we have compounds. An element is something you would find on the periodic table of elements. Okay, so periodic table of elements. And this is where you have only one single particle. Okay, so also known as atoms, which we will get into later on in this unit. So if you're drawing, let's say, a particle picture here, and we're drawing an element, elements are drawn as single circles. So there's nothing connected to it. It's like a single circle or single whatever. I mean, it could be a triangle, but it's one type of particle. They're all the same, and they're a single circle. If you're looking at the periodic table, or if you have the element symbol, okay, so for example, gold is AU, right? Hydrogen is a capital H, right? Silver, we looked at before, is capital A lowercase g. So how do you know you're looking at the symbol of an element? All element symbols start with a capital letter. So notice capital A, capital H, capital A again, capital O for oxygen, capital C. Calcium is Ca, another capital C. But you only have one capital letter. As soon as you see more than one capital letter, that tells us that we have more than one element in that particular particle. Okay, so when it looks like more than one, you have a compound. So a compound is where you have two or more particles that are chemically combined. So notice here is an example, carbon dioxide, CO2. That means that we have two types of elements that are together in this one particle. So when we're drawing a particle picture of a compound, okay, you're going to see that there's going to be two or more connected circles. But remember, if it's a pure substance, that means you have the same type of particle over and over again. So just to refresh, so an element would be one single circle, right? And it doesn't matter the type it is, but if it's a pure substance, it has to be the same type of particle over and over again. So all three of these, and actually let me draw another example of a compound. Okay, so all four of these, A, B, C, and D, these are all pure substances. So meaning in that block of that type of matter, it's all the same particle on repeat. So for A, we have these single white circles that are there. B, we have single purple circles. For C, we have a compound made up of one white and one purple circle, right? So this would be like one compound. But because it's the same compound repeated over and over again, that's what tells us it is a pure substance. D is also an example of a compound. Okay, it looks different than C because now we have two white circles and one purple circle, but it's still considered to be a pure substance because it's the same type of particle over and over and over again. So again, how are you going to know that you have an element instead of a compound? Elements are single atoms or single particles alone A compound means you have at least two that are connected to each other. So when we say that they are chemically combined, that's what we mean. They are actually connected to each other. So when you see the particle pictures, they will be connected. Right? So here's another example. Right? They don't have to be the same size or shape or color, but they have to be actually connected, right? So again, this is a pure substance because they're all the same, and they can be twisted around too. They don't have to be in the same direction. It just has to be the same type of particle. So this is one big white circle and two little purple circles, and this is a compound because it's the same particle over and over and over again. An element, right, is where you have, again, it's a pure substance, but they are single and they're repeated. They're all the same type of particle. Okay. Now, when you're looking at the chemical formula for that, how do you know you have a compound versus an element? The chemical formula of a compound will have more than one capital letter. So carbon dioxide, CO2. So the little number actually tells you how many of each one you have. So there's one carbon and two oxygens, right? Look at water, H2O, two hydrogens, one oxygen. But the point is, what makes this a compound is that it has hydrogen and oxygen together, right? Salt is another one, NaCl. There are two capital letters. And there could be more than two, right? So let's say we had a sugar. We have three capital letters. But as soon as you have more than one, you have a compound compared to an element. Now, there is one special type of pure substance, okay, that looks very unique. Okay, so I want you to notice a difference. So both of these are pure substances, okay? The one on the right, actually let's do 3 versus this, okay? So the one on the bottom for sure is an element because we can see that they are single circles. Over here on the right-hand side, we have a compound. And how do we know? Because we have two different types of circles. But remember, it could be 2 or more, right? I could have something like this, right? 3 white circles and 1 purple circle, right? So it's a pure substance because it's the same, this thing repeated. And I know it's a compound because there's more than one different type of particle that is chemically connected. Now, this one over here on the left is technically considered to be a compound because there are 2 particles that are connected, but they're the same particle connected. This has a special name. It's called an element. It would help if I spelled it correctly, wouldn't it? It's called an elemental compound. So what that means is it is a compound because you have more than one circle connected, but it's technically the same element connected to each other. They're not different elements. So for example, if I had F2, so there's only one capital letter, but the 2 tells me that there are 2 of those that are connected, right? So an elemental compound is unique because it's the same element, but there is more than one that is chemically connected. So it's still classified as a compound, but we have to make sure that we include the fact that it's a elemental compound. So if there was more than one capital letter, so let's say we had HF, for example. So that means we have one hydrogen and one fluorine. This would just be a regular compound because there's two different types of elements that are in this. But when it is the same element connected to each other, this has a special category name. It's called an elemental compound. Okay, but remember, all these examples we're looking at, these are pure substances because in that block of matter, it's the same thing on repeat. The only difference is you're either repeating one particle or you're repeating a cluster of more than one that is connected together, which is a compound.